Hello students, welcome back to my channel Positron. Dear students, my last videos were based on the motion in one dimension. I have discussed with you are unit and dimension, dimensional analysis, error analysis, and today's topic is a vector analysis, right? You know, in the physics, the physical quantities are basically divided into two types, scalars and vectors. Physical quantity that is divided into two types, scalars, vectors. Actually, division is four types. That is a true scalar, pseudo scalar, true vector, pseudo vector. But we have not to study up to that level. Scalars are what? Those quantities to represent which we need only the magnitude are said to be the scalars. For example, distance, speed, time, mass, all kind of energy, electric energy, potential energy, gravitational potential energy, solar energy, all kind of energy and work are the part of scalar. Dear student, very interesting. Pressure is that is force acting on unit area. Force and area both are the vector quantity. Despite pressure is a scalar quantity. Pressure is also a scalar quantity. Actually, in the pressure, the direction is predefined. This is said that the normal force acting per unit area means perpendicular force acting on the area. So the direction is already defined. That is why pressure is a scalar quantity. Now let's talk about the vectors. Distance is a scalar, so displacement is a vector quantity. Speed is a scalar, velocity is a vector quantity. Now it's a force, acceleration, momentum, impulse, and so many quantities are there which are vector quantities, right? As we will move ahead, so many, you will be acquainted with many quantities, many new quantities. At the very time we will discuss about whether they are scalar, vector, what is their unit, what is their dimension. So these things that you have not to mug up actually, right? Just you should know about that, and as we will move in the next topics, the new topics you will move through, there will be many new physical quantity. At that time we will discuss their properties, means whether they are scalar, vector, unit, dimension, so many things we will discuss. Now dear students, this is all that we have taken the two division. That is, a physical quantity is divided into two types. One is a scalar and the is a vector. Scalar, a quantity to represent which we need only the magnitude, and vector, a quantity to represent which we need magnitude as well as direction. That is said to be the vector quantity. Now dear students, I have said that actually the division is four types. In higher level you will study, that is a true scalar, pseudo scalar, true vector and pseudo vector. But at your level this is sufficient. Now dear students, next comes, that is a representation of vector. Representation of vector. How you can represent a vector? You know, a vector quantity is one that have the magnitude as well as the direction. Now dear students, what is that? A quantity vector A is any physical quantity, that is a vector quantity So vector A I am representing by this arrow. Now the length of this arrow is actually, this length is the magnitude of vector A, right? And this is representing the direction of vector A. Actually, this arrow has the two things. One is a direction and another is the length of this arrow is representing actually the magnitude of the arrow. So vector A, that is direction, is represented by this this head, and the length of this arrow represents the magnitude of vector A. Now dear students, let's move further. The type of vectors. Type of vectors. How many kind of vectors you know about? That is in how the vectors can be classified further. Dear students, there is a 4 division. First one is a like vector, like or equal vector. Second one is a unlike or opposite vector. Third one is a unit vector. And fourth one is a, that is a zero or null vector. There are 4 divisions of the vector. First one is a like or equal vector. Second one is a unlike or opposite vector. Third one is a unit vector. And fourth one is a zero or null vector. Right? Let's discuss one by one. As initially I have said that vector is a physical quantity to represent which we need magnitude as well as direction, right? So equal vector from was, it is clear, from the name it is clear that the two vectors having equal magnitude. But vector is equal, it means not only the magnitude as well as the direction should be equal. Direction should be same. If the two vectors having equal magnitude and direction, then they are said to be the equal vectors. For example, like or equal vector is, let it is a vector A and another is a vector B. Now look here, dear student, we are assuming, we are expecting that both the vector has the same magnitude and they are directed in the same direction. In this condition, vector A will be equal to vector B, and also you can say mod of vector A is equal to mod of vector B, right? Means they are equal in magnitude and equal in the direction, so they are said to be the equal or like vectors. Now dear students, how you can make? Now we have to unlike our opposite vector. The two vectors, now look here, again I'm assuming that the two vectors having equal magnitude, right? But they are directed opposite to each other, then they are said to be the opposite vector. For example, vector A equal to minus vector B. Minus vector B is what? This is a vector A, right? And I have taken a vector equal in magnitude to vector A but oppositely directed. Let it is a vector A, right? If I will reverse this direction, it will become minus vector A. And now minus vector A is equal to vector B. That is why it is written as A is equal to minus vector B. What I have taken? This was the vector A. Now I have taken the magnitude same. I have considered another vector which has the same magnitude but directed opposite. So if it is vector A, so it is a minus vector A in this way. And now this vector is equal to vector B, and that is why vector B is equal to minus vector A. It means if vector A is given and you consider another vector equal in magnitude to vector A but oppositely directed, then that will represent minus vector A. Now let's come. The third one is a unit vector. This is a very important mathematical calculation. Most of the time you will come across with this vector, because in solving the calculation, in solving the questions, numerical problems in physics, it has a very important role to play. Now, dear student, unit vector is what? Let vector A is a physical quantity which is a vector quantity, right? A is a physical quantity which is a vector quantity. Because it is a vector quantity, so it has the magnitude and direction as well as both. So I'm just separating it. It's a magnitude I'm writing by mod of vector A, and its direction is I'm writing by n cap. Vector A is a physical quantity which is a vector quantity. Dear student, look here, the two representations I am considering, one is a vector A and that is A. What is the difference between them? Difference is that here I am not very sure, if you are not putting the cap or you are not putting the vector, sign of vector over this quantity, then I am not sure whether A is a vector quantity or a scalar quantity. From it is clear that you can write vector A, and now look here, from this it is clear that A is a vector quantity. And if A is a vector quantity, then mod of vector A, that is means we are concerned only with the magnitude, and that is A actually, right? So if A is a vector quantity, then write like A is it has only the magnitude. But if A is a vector quantity and if you want to represent its magnitude, then write like this, mod of vector A. Mod of vector A, what represent? It says it represents completely to the quantity A, that A is a vector quantity of which we are concerned only with the magnitude. Actually, mod of vector A and A both are the same, both are representing the magnitude of a physical quantity A. But the difference between them, from A, it is not clear that whether it is a scalar or vector, but if you write mod of vector A, it is clear that A is a physical quantity which is a vector quantity of which we are concerned only with the magnitude. Now, dear students, A is a vector quantity. I am separating its magnitude and direction as well as. So, I am writing vector A is equal to mod of vector A into n cap. Now, look here, you can write n cap is equal to vector A upon mod of vector A. N cap is a unit vector that is representing, that has the magnitude 1 unit, and it represents only the direction. What I have done here, A is a physical quantity which is a vector quantity. Vector A is equal to, I have written mod of vector A into n cap. So n cap is a mod of vector A is a magnitude of vector A, and n cap is a vector which has a unit vector which has the magnitude 1, represent the direction of direction only. In this case, it is representing the direction of vector A. So n cap is equal to vector A upon mod of vector A. Now, dear students, you can say n cap is equal to vector A upon mod of vector A, means unit vector of a vector, of any vector, is that vector divided by its magnitude. Unit vector of a vector is what? That is, it is a vector divided by its magnitude gives the unit vector of that vector. Now, third one is a zero or null vector. Zero or null vector. Zero or null vector. A vector which has the magnitude 0 but has the direction is said to be the zero or null vector. A vector which has the magnitude 0 but has the direction, right? This is said to be the null vector. Just after this topic, you will study that what is that. For example, I am giving right now, because this is relevant to tell you here, that example of null vector, if 3 or more vectors, 3 or more regular vectors are added in such a way that they form a closed shape. If 3 or more regular vectors are added such that they form a closed shape, then their resultant will be a zero vector. Three or more vectors, three or more regular vectors are added and they form a closed shape, then their resultant would be a zero vector or null vector. For example, let it is a vector A, right? Regular vector means vector B on keeping on the head of vector A and drawn a vector B, right? On keeping on head of vector B, the tail of vector C, I have kept on the head of vector B and drawn a vector C. And now the fourth vector, that is this is vector D, right? Now the A, B, C, D are regular vector. Regular vector means the head of one is meeting to the tail of further one, right? Or the tail of a vector has been kept on the head of predecessor, right? So the tail of this is kept on the head of this, tail of C is kept on the head of B, and tail of D is kept on the head of C, and they are drawn to meet, and ultimately they form a closed shape. So their resultant vector A plus vector B plus vector C plus vector D is equal to vector 0. Now question is that why I have said that three or more vectors or more regular vectors formed to a closed shape are said to be the zero vector, simply because less than the three vectors, two vectors cannot form a closed shape. Like for example, it is a vector A, it is a vector B. Anyhow, you cannot make a closed shape. For making the closed shape, it requires at least three vectors. That is why I have said that if three or more vectors are added such that their resultant are added such that they form a closed shape, then their resultant will be a zero vector. Vector A, for example, here, for regular vectors I have considered A, B, C, D, and their resultant is a vector A plus vector B plus vector C plus vector D, and that is equal to vector 0. Now, dear students, let's move further. This is the four vectors I have divided. This was the division of four vectors. Dear students, magnitude of vector, after that we will study. Now look here, I have said that four types of vectors I have discussed. The physical quantities are divided into two types, scalars and vectors. Many quantities I have told you all, and about scalar, many quantities I have described with you all about the vector. And then the four types of vectors are what? Like are equal vectors, unlike are opposite vectors. Third one is a unit vector, and fourth one is a zero vector. Now, dear student, the four important operations that you have studied up to the 8th standard, like addition, subtraction, multiplication, and division, that you have studied, you are familiar. Three operations that we have to study here. The three operations are the addition of vectors, addition of two vectors, three vectors, four vectors, or many vectors, and subtraction of vectors, and then multiplication of vector. Now we have to find out that what is the difference between the addition of two vectors, three vectors, four vectors, or addition, how it is different from the addition of scalars. Now dear students, so we are moving on. The next topic is addition of vectors. Addition of vectors. Dear student, there are many methods for the addition of vector. One is a law of polygon, law of triangle. Second one is a law of parallelogram. And third one is a law of polygon. Actually, these two laws are important, are more relevant when you are adding the two vectors. What I have said that we are going to study the addition of addition of vectors. The addition of vector is done in three ways. One is a law of triangle, second one is a law of parallelogram, and third one is a law of polygon. Dear students, let's move. First, we'll study law of triangle. Law of triangle and law of polygon, law of parallelogram are more relevant, are more significant when you are adding the two vectors, right? And after that, if you are adding 3, 4, 5 vectors, then undoubtedly it's a law of polygon is a more significant, more easy, more convenient. Now, dear students, first just by law of triangle, we are going to study the addition of vectors. We are adding two vectors using law of triangle. Very simple. Let it is a vector A, right? And you have to add vector B in this, okay? This is a vector A and you have to add vector B in this. How will you do? Simply, law of triangle says, I have drawn a line parallel to vector A and equal in magnitude, right? Whatever be the length of it, the same length, line of same length and parallel to vector A I have drawn. If it is a vector A, then this is also vector A. Now, keeping the tail of vector B on the head of vector A, I have drawn vector B here. Now, I have drawn here vector A, right? Vector A how? A line equal in magnitude to vector A and parallel to vector A. So, if it is vector A, the same, here it is vector A. Now, on the head of vector A, I have drawn a line parallel to vector B and equal in length. And if it is vector B, it is also vector B. Now, dear student, draw a line to meet initial and final point. And the direction of resultant will always be from initial to the final. So it is vector R is equal to vector A plus vector B. Dear students, what I have said that this is a vector A, this is on the head of vector A, we have drawn a vector B, means a line equal in magnitude to vector B and parallel to vector B. And now we have drawn a line meeting initial and final point. The direction of resultant is always from initial to the final point. So the direction of our resultant is from the initial to final point. So vector R is equal to vector A plus vector B. In this way, using the law of triangle, we have added the two vectors, vector A and vector B. Now, dear student, how you can use this? Using, we have to add these two vectors. We have to add these two vectors using law of parallelogram. Second one is that we are adding the two vectors using law of parallelogram. How? Dear students, this is a vector A and this is vector B, and they are making angle theta with each other. In such a case, it is a very important. If the two vectors are entangled to each other, then more relevant, more convenient is to use the method of law of parallelogram. Law of parallelogram, where we will apply in the case when the two vectors are entangled to each other, then law of parallelogram is a more convenient. Here the two vectors are vector A and vector B and they are making an angle theta with each other. We have to add them. Dear student, nothing special I am going to do. Simply from head of vector A, I am drawing a line parallel to vector B and equal to vector B. Right? Now, if this is vector B, this is also vector B, because these two are equal in magnitude and parallel to each other. They are parallel. It means just draw a line moving further. And if this angle is theta, then this is also theta, right? And that is why they are parallel. They are parallel means they are making equal angle with the x-axis. Now, dear student, again the same thing I am going to do. I am drawing a line to meet initial and final point in this way. This is the resultant. R is equal to vector A plus vector B. What I have said, that the addition of vectors can be done in many ways, like law of triangle, law of parallelogram, law of polygon. But what I am saying, that law parallelogram is useful, is convenient when the two vectors are entangled, when the two vectors are making an angle with each other. Here the case was that the two vectors A and B are entangled, are making, subtending an angle theta with each other. Now, what is that? Here it is a vector B. I have drawn a line parallel to vector B, equal in magnitude to vector B. If this angle is theta, then this should be theta. Only then this will be parallel. If it is vector B, this is vector B. From initial point, I have drawn a line that is meeting initial and final point. This will represent the resultant vector, and the direction of resultant vector will be from initial to the final point. This is a from here to here. This is a resultant vector. R is equal to A plus B. Now, dear student, look here. It is a vector B. From the head of vector B, I am drawing a line parallel to vector A like this, and it meets here, right? And this line and this line is equal in magnitude. If it is vector A, this is also vector A. Now you can say that R is equal to A plus B, and in this case it is actually B plus A, right? In this, resultant is the same. Either you add vector B in vector A, or you add vector A in vector B. In both the cases, your resultant is the same, right? So, R is equal to A plus B in this case, and R is equal to B plus A. Here, A plus B means you are adding B in the A, and B plus A, you are adding A in the B. In both the cases, resultant is the same. Then you can say that R is equal to vector A plus vector B, and that is equal to vector B plus vector A. It means addition is addition of two vectors. This property is said to be the addition of two vectors is commutative. Addition of two vectors is commutative, you can say in this case. Now, dear student, in this way, using the we have added the two vectors, vector A and vector B, and proved that using law of parallelogram, and proved that the addition of two vectors is commutative. This is it means either you add A in B or you add vector B in vector A. In both the cases, resultant will be same. Now, dear student, a very important thing you can prove using this picture, using this figure. Again, I'm just the same problem I'm considering. This is look here, it is a vector A, and this is vector B, right? I have drawn from here vector B. This angle was theta, so this angle is also theta. Now I have drawn a perpendicular from this, and now drawn a line meeting to this. This is a vector R, and that is equal to vector A plus vector B. Now, dear student, the magnitude of this line is actually A. Magnitude of this line is actually B, and this is a vector R, means it is consisting the magnitude as well as the direction. The length of this vector is R actually. Now, how on the basis of how the magnitude of of vector r you can calculate by using this picture. If vector A and vector B are making an angle theta with each other, if vector A and vector B are subtending an angle theta with each other, then how you can calculate the magnitude of vector r? There is a formula you can derive. Now dear student, let it is x in this triangle, it is x and this is y. If you consider cos theta is equal to base upon hypo, x upon b, that is x equal to b cos theta. And again you can consider sin theta is equal to perpendicular upon hypo, that is y equals to b sin theta. This is a b sin theta. Now dear student, look here, in this right angle triangle, you can apply the Pythagoras. The square of hypotenuse is equal to the sum of square of two other sides. That is a square of this is what? R square, right? It is a vector R, resultant vector R, and its magnitude will be R, right? So square of this magnitude, R square is equal to square of this magnitude. This is A plus B cos theta, because up to here the magnitude is A and this is B cos theta, so it is A plus B cos theta square of base plus square of perpendicular, that is a B sin theta square. So you can write R square equal to A square, A plus B whole square, you know, A square plus B square plus 2AB. So A square, rather here is a B cos theta, so square of it will turn B square cos square theta plus 2AB cos theta plus B square sin square theta, writing here to that term. Now dear student, B square cos square theta and B square sin square theta, if you take B square common, sin square theta plus cos square theta result into 1. So you will get R square is equal to A square plus B square plus 2AB cos theta, R resultant is equal to under root A square plus B square plus 2AB cos theta. In this way you can find out the resultant of a vector, right? Resultant, the two vector A and B are subtending an angle theta with each other. In this case the resultant works out to be R is equal to under root A square plus B square plus 2AB cos theta. Let the resultant vector R is making an angle phi with the vector A, then how you can find out the angle phi? I'm very sure that you people are following. If you have a problem, do comment, then I will try to let you understand. I will try my best to make you familiar with the physics. Now dear student, in this way let's move further. That is it. Now what we have to do, we have to find out, let phi is the angle that the resultant is making with the vector A. Now how you can find out the value of phi? Now look here, in this triangle, right, tan phi is equal to perpendicular upon base. Perpendicular is what? That is B sin theta upon base. Base is that much, that is A plus B cos theta. In this way you can find out. But tan phi is equal to B sin theta upon A plus B cos theta. This is true only when the phi is the angle that resultant is making with the A. It might be, this is, if the phi is the angle that is making with vector B, in this case you will get some different result, right? So here what I have done, that phi is the angle that resultant is making with the vector A. This very formula is a very important. In NEET examinations, many times questions are based on this. For example, the question may be like that: the resultant is making an angle 90 degree, or resultant is perpendicular to vector A. In that case, tan 90 is a sin 90 over cos 90. That is a sin 90 is a 1 and cos 90 is 0. 1 by 0 multiply is equal to that. 0 will be multiplied with that. So a plus b cos theta multiplied by 1 means a plus b cos theta is equal to 0, or cos theta is equal, if look here, a plus b cos theta is equal to 0. In that case, cos theta is equal to, bring a to here, that is minus a upon b. If you know the value of a and b, you can find out the angle theta between a and b. Theta is a what? Theta is the angle between a and b. In this way, from this very question, you can prove that. You can find out the angle between a and b. Question might be asked like such that the resultant is perpendicular to vector a, then find out the angle between vector a and vector b, whereas the magnitude of vector a and vector b is that so much. If a magnitude of vector a and vector b is given, just you can use this wave formula and you can find. Now, dear student, here we are studying addition of two vectors. The two methods I have told you all. That is a first method we discussed, that is a law of triangle. I have said that law of triangle is a relevant, significant when the two vectors are given. But if the two vectors, like the two vectors, this is a vector A and this is a vector B, they are separately given, right? Then law of triangle is a more relevant. But if it is given such that the two vectors, vector A is this and vector B is this, right? Vector A and vector B, and they are subtending an angle theta with each other, they are making an angle theta with each other, they are entangled at an angle theta with each other. In such a way, in such cases, the law of parallelogram is going to be more relevant, more important, more convenient, more easy for you. In that case, what we have proved? We have proved that the addition of two vectors is a commutative, means vector r is equal to commutative, means vector r is equal to vector A plus vector B, or that is equal to vector B plus vector A. It means that either you add vector B in vector A or vector A in vector B. In both the cases, resultant is going to be the same. And also what we have found, that if the two vectors A and B are making an angle theta with each other, in that case, R is equal to the value of resultant, the magnitude of resultant, that going to work a square plus b square plus 2ab cos theta. You can find out. And also you find that tan phi is equal to phi is the angle that resultant is, if the resultant is making an angle, this is the resultant and it is making an angle phi, then tan phi is equal to b sin theta over a plus b cos theta. This till now we have find out, right? This is the method of adding the two vectors. Third one is a, dear students, that is a law of polygon. Law of polygon is what? If there are number of vectors you have to add, like this is a vector A, vector B, keeping the tail of vector B on the head of vector B, we have drawn like this. Another vector is a vector C, keeping the tail of vector C on the head of vector B in this way. This is the vector C. Then it is a vector D, right? The four vectors we have to add, vector A, vector B, vector C, vector D, they are given, they are represented separately. Now we have to add. What I have done? I have drawn first to the vector A, and keeping the tail of vector B on the head of vector A, I have drawn vector B. Again, I have drawn vector C, keeping the tail of vector C on the head of vector B, drawn vector C. From the head of vector C, keeping the tail of vector D, drawn vector B. Now we have drawn a line meeting initial and final point. This represents the resultant, and that is a vector A plus vector B plus vector C plus vector D. In this way, using the law of polygon, directly you can find out the resultant of many of vectors. But even by using the law of triangle, you can find this resultant. First you added vector A, B in vector A. Let this resultant is vector R1. And now vector C we have added in vector R1, right? This is the vector R1. On the head of vector R1 is what? That is a resultant of vector A and vector B. On the head of vector R1 we have drawn, keeping the tail of vector C, we have drawn vector C, and now this works out to be, this is a vector R2, and that is equal to, this is how does it comes? This is the resultant of two vectors A and B. I mean R1 is added with, or C is added with the resultant of A and B, that is R1. And now in this resultant vector D is added, and so you have got R. So you can write R is equal to R. If we can write in this way, R is equal to R2 plus D, right? Now R2 is what? R1 plus C. Now R1 is what? Vector A plus vector B. And now here the two things, vector C plus vector D. In this way you can write, right? This way, in this way we have just, I have tried to explain, that is all. The three methods of addition of vector I have discussed with you all. First one is a law of triangle, second one is a law of polygon, and third one, the last one that I have discussed, that is law of polygon. Now dear student, I have the properties of addition of two vectors, that is a two vector, the addition of two vector is a commutative, means vector A plus vector B is equal to vector B plus vector A. It means either you add vector B in vector A or in vector A in vector B, the resultant would be same. What is one important property is a associative property. You can prove this. Associative property is what? Associative property is what? We have proved that the law of addition of two vectors is a commutative. The two vectors A and B, if their angle between them is theta, then their resultant, the magnitude of resultant R is equal to under root A square plus B square plus 2AB cos theta. Dear student, how you can differentiate between the addition of two vectors or addition of two scalars? The two scalar quantities, let their magnitude and 3 and 5, then if you will add them, then that is 3 plus 5 is equal to 8. The two scalar quantities have the magnitude 3 and 5. Let the two distance is a scalar, time is a scalar. Let the two times are given 3 hour and 4 hour. Then there 3 hour and 5 hour. Then their addition will turn it to be 3 plus 5 is equal to 9 hours. Dear student, but what happens? Now, what I'm telling you, I'm just trying to differentiate between the addition of two scalars and addition of two vectors. How these two things are different. Now, you add the two scalar quantities, the addition will result 3 plus 5 is equal to 9 hours. Either you say that one student studied up to 3 hours, another student studies every day 5 hours, then total their combined studies at 3 plus 5, that is, 3 plus 5, that is equal to 8 hours. Now, dear student, but what happened? Let's talk about the force. The two forces are 3 Newton and 5 Newton. Now, first we have considered a scalar quantity, that is time. The two students were studying, one was studying 3 hours every day and another was studying 5 hours every day. Their combined study works out to be 3 plus 5, that is equal to 8 hours. Now what happens if the 3 and 5 have been associated with the vector quantity? Let the two forces, this is a trolley, and the two forces 3 and 5 are acting on this trolley. Force is a scalar quantity. A child is applying 3 Newton force, another child is applying 5 Newton force. You know the net force becomes 5 plus 3 is equal to 8. Now a child is applying 3 Newton force in this way, another one is applying 5 Newton in this way, you know, you have to subtract. That is 5 minus 3 is equal to 2 Newton. Now, a man is applying 3 Newton force in this way, another one is applying 5 Newton in this way, and these are at 90 degree to each other. In that case, resultant will be R is equal to under root 3 square plus 5 square, that is a 9 plus 25 under root 34. That is. It means in the vector, the angle between them is also relevant, right? At what angle the two vectors are acting, this is important and it has an impact on the resultant. Now, associative property is what? Dear student, it says associative properties, it says vector R is equal to A plus B plus C or A plus B plus C. What does mean to this? Means in this case, resultant of vector A and vector B has been added into vector C, and in this case, vector A is added in the resultant of vector B and vector C, and both the cases are equal because in both the cases resultant is a vector R, means both are equal, and this is said to be the associative property. Now we have to prove that. Dear students, look here, let it is a vector A, this is the vector B, and this is the vector C. And you know, draw a line meeting initial and final point, it is a vector R, and that is equal to simply vector A plus vector B plus vector C. This is. We have separately added vector A, vector B, vector C, and resultant is this vector R, and the direction of resultant is always that I have said that from initial to the final point, that is R is equal to A plus B plus C. Now, how we will get the resultant according to these equations? First, A plus B means A is added in B or B is added in A. The resultant will be this. This is vector R1 is equal to A plus B. Now, resultant of this is vector R1. C is added in vector R1, and now this is the resultant is R is equal to R1 plus C. Now dear student, what is this? B plus C. First clear B plus C means C is added in B. Let it is a vector R2. Vector R2 means C is added in vector B. Resultant is R2 is equal to B plus C. Look here. Now A plus, you can say it is A plus R2. R2 is added in vector A. Now this is the R2 and it is added in vector A, and again the same resultant you are getting, that is A plus R2. Now you can say that this equal, because R1 is A plus B, right? Means either you add C in the addition of A and B, or you add A in the addition of B and C, the resultant would be same. This is the associative law. With this is the end of video today. I hope if you are following, you all are following to me. If you have a problem, do ask to me in the comment. I will try my best to let you explain. Least but not last, dear student, if you think my videos are helpful in your studies, then please and please share, subscribe and comment, and must put the bell icon so that you might be notified about my next video. Till then, meet you in next video. Till then, bye.